Alright guys, we're going to go through what we did in class here again today with this Discovering Pi lab. So you have this um, lab report which I've actually uploaded to your Google Drive, so you're going to actually um, type in your responses to this, okay, in terms of your hypothesis, procedure, your data analysis, and your conclusion, okay? And so we'll talk about what to expect from this as we go through the exercises, okay? We've got the hexagon, octagon, dodecagon, and icosagon that we're looking at. Um, what is the method of discovering pi is as follows, okay? So we're proposing that as you take uh, polygons with more and more sides, regular polygons with more and more sides, okay, and take the ratio of their perimeter to their diameter, then that's going to start approaching pi. That's going to start approaching pi. So here we have an octagon, okay, and the ratio of the perimeter of the octagon to the diameter is, as you can see, 3.06. When I moved up to a 20-sided figure, the icosagon, look at that, my ratio got to 3.13. All right, now it will never get to pi until it's a circle. But if you want to keep increasing the number of sides, then that ratio is going to get closer and closer to pi. So let's show you how we create all these again, just in case you forgot. Okay, so I'm just going to start with another document here, and okay, add a page, which you were to do too. You added 4 pages, one for each of the polygons. Okay, so here we go. We start off with a circle, any circle of any size, doesn't matter. Okay, what I say, let's see what I'll do here. I'll do the hexagon. Okay, so I'm just going to grab my text box over here. I'm going to say the hexagon, which of course is 6 sides, and the angle of rotation is equal to 360 divided by the number of sides, which in this case is 6, so the angle of rotation is 60, and that's important. So, of course, if we're doing a octagon, it's 360 divided by 8. Let me just put in here, generally speaking, number of sides. So that, in this case, we know it's 60. In an octagon, we know it's 45. In a 12-sided polygon, which we said was a dodecagon, it's 360 divided by 12, so which means the angle of rotation is 30. Now, what is the angle of rotation? Okay. Again, we double-click on the center of the circle. We have the pointer tool activated. Double-click on the center of the circle until we get that effect that's marking the center. We then click on this point on the circle, and then we go to the transform menu. We choose to rotate each time by 60, so we're going to have to type in the 60 there, rotate, okay. With that highlighted, we can just keep on doing that process over and again, rotate again, just keep doing it until you move your way around the circle, and effectively, in this case, you're going to do it 6 times, okay, transform, rotate, okay, transform, rotate. And now we've gone completely around, so we're going to select all 6 points of that that are 60 degrees apart, and we're going to choose to construct the segments through those. Oh, something went haywire there because I didn't want that, so I'm just going to undo. That's because I seem to have gotten that the center point highlighted, so I'm just Control Z to undo, and I'm just going to deselect that point and then go and construct. It should be all right now. There's my regular hexagon, okay? Now, I want the side of the hexagon, so I click on, I go to measure the length, okay? Pull this out. With this highlighted, if I right click, I can go to label, and I can change that and say that's the side, okay? So that looks a little cleaner, side, okay? I need the perimeter. Now, what is the perimeter? Well, I got to go to my number menu, okay, and I need to calculate, and it's the side times 6, because it's 6 sides, so the perimeter is always the length of one side times the number of sides, in this case 6, and there goes my perimeter, and I'm just going to, again, label that as perimeter, capital P. All right, got that. And I need my diameter. So with my segment tool, I'll go through the center of the circle on 2 points on the circle. I'll measure that. I'll measure that length, and I'll tag that again with a right click over here as the diameter. And let's put a capital in there. Okay, and now the ratio of the perimeter to the diameter is going to be approaching pi. So let's go to the number, calculate, and do the perimeter divided by the diameter, and that is, in this case, 3. Okay, so, and that shouldn't matter the size of your circle, as you can see. I'm going to change this around, okay, but my values for the side, the perimeter, and the diameter change, but that ratio remains constant at 3, okay? So when we graduate up to a octagon, let's see, do I have an octagon? I have the octagon here, and I did the same thing on the octagon and saw that the ratio perimeter diameter was there, was 3.06, so let's move a little closer to pi. Then we went to this is the dodecagon, so that's the 12-sided figure, and of course the angle of rotation there is 30, and we're moving closer to pi at 3.11, and again, doesn't matter the size of this, okay, that ratio is going to be the same, okay, and then we move to the 20-sided figure, and you say, well, really, I don't see the difference between the polygon and the circle. Well, there is a difference, and if you pull on it, and pull it out, you'll see, as you make that larger, you can see there is a distinction between the circle and the polygon. But indeed, that's why we're getting pi, or that's why we're approaching pi, because this figure with these 20 sides is looking more and more circular, okay? And therefore, that ratio of the perimeter to the diameter is going to be approaching pi, okay, more and more. So if we wanted to go up to a 40-sided polygon, we can be even closer to pi, okay? So you need to have a Sketchpad example of this, which you're going to upload. Your finished product is going to upload as assignment number 6, okay? And then you need to go into your Google Docs, and in your Google Docs, rather in your folder, geometry folder of your Google Docs, you need to access this Discovering Pi Lab sheet and fill out the hypothesis. Well, what do we expect to happen? We expected that as this number of sides grow, the ratio between the circumference, or the ratio between the perimeter and the diameter, gets closer and closer to pi. What did we do? We constructed those multi-sided polygons as we showed you there, and then fill in that data with your particular values here and draw some conclusion, okay? Hopefully that this is actually moving towards that value of pi. All right, so there you have it. Have fun with that, and I hope to get those all from you for the next class uploaded to your geometry folder in your Google Drive. Okay, enjoy.